One. So yeah, our stream is live now. So I think we can bring up our quick agenda slides to introduce what's going on today. So today is kind of a special event. It was organized in collaboration with IBM data science community. So IBM is a sponsor of NumFocus, which is our parent organization. So what's on the menu today? So today we have two speakers, both from IBM. So we'll have Frederick Reiss, who will talk about text extensions for Pandas. So as usual, his presentation will be for about half an hour, and we're also taking into account questions. So everyone who's right now watching to this live stream, feel free to post your questions in the YouTube comment section, and we'll be taking occasional breaks to read those questions back to Fred. And after that, Luciano Resende will introduce Elyra, which is an extension to JupyterLab. Oh, yeah, and there will be some final wrap-up notes, and that is it. So Fred is principal research staff member at IBM Research. He's also a chief architect at IBM CodeData, if I pronounce that correctly, which is, I guess, a division of IBM focused on open source software and artificial intelligence. And Luciano is an open source AI platform architect at IBM CodeData. So I'd like to pass the stage to Tim, who's a member of IBM's data science community, and he's going to talk about what it's all about.
All right. Hi, everyone. Greetings from the West Coast. I'm in San Jose. I'm part of the IBM data science community team. We are a venue for people interested in data science, AI, machine learning, whether IBM customers or people that are interested in some of these open source efforts that you're going to be hearing about today, to learn together, to share what they're working on, interesting resources, and definitely a place to check out. We have over 16,000 members and counting. If you decide to join, there's a couple of offers that might sweeten the deal a little bit. One is a free access to a Manning Live project, and the other is a virtual event that we're partnering with another organization on, Data Science Salon, that's coming up in May. That should be quite interesting. So if you want to get free tickets to that one, I will definitely share. We'll definitely share the links in a moment. Yeah, check it out and enjoy tonight's event. Have fun.
Right. So Fred, the floor is yours.
Thank you. I'm going to turn on my screen sharing here. Try that one more time. Okay, I can see my screen. That probably means everyone else can see my screen. And now we should be able to see my title slide. We looking good?
Oh, good. Yes.
Thumbs up from Maria over there, so we are good. So welcome everyone to my talk at this meetup. It's going to be about text extensions for Pandas, and you'll find out what is text extensions for Pandas a couple slides in. First, a little bit about me. I'm Fred Reiss. I am coming to you today from California, and I've been in California for quite some time now. I went to grad school at UC Berkeley, graduated from there in 2006 with my PhD in data management, and then joined IBM Research immediately in 2006, and I am still part of IBM Research. Also in 2015, I took on an additional role as chief architect for our open source lab in San Francisco, the Center for Open Source Data and AI Technologies. But enough about me. Let's talk about you. Now, if we were doing this in person, this would be the part of the talk where I ask everyone to raise your hand if you know about Pandas, but you don't know anything about natural language processing. Now, in this live stream format, that's a little more awkward, but I'm sure that Some of you in the audience are in this category. You know Pandas, but maybe not so much about NLP. If you're in this group, then this talk is for you, because we're going to be introducing core NLP concepts. We're not going to assume any knowledge of natural language processing, but we're going to show you how, if you decide to get in and do some natural language processing, you can use your existing Pandas skills to be more productive in the NLP domain. Now, there's probably a second group of you out in the audience who know about natural language processing, and you do natural language processing maybe as part of your job, but you don't use Pandas when you're doing natural language processing. Maybe you use it when you're not doing NLP, but for NLP, you're not using Pandas. If you're in this second category, then this talk is for you, because we're going to show you how you can do tasks that today are fairly time-consuming and difficult, and make those tasks that are part of your NLP workflow, and make those tasks much more easy by using the power of Pandas data frames. Now, there's one more group probably in the audience, probably represented by a few of you, where people who are already using Pandas for natural language processing. You're already doing both of these. Well, if you're in this category, then this talk is for you, because we're going to be introducing extensions to Pandas data frames that will bring Pandas beyond what you already are able to do with it, and be able to cover more of your NLP workflow and do even more of your NLP tasks with the power of data frames, and be even more productive. So that's an overview of what we're going to talk about and who this talk is aimed for. So let's get into the talk. Now, as far as natural language processing goes, I joined IBM in 2006, and I started working on natural language processing research in around 2007. Now, in the past 14 years, the NLP field has undergone quite a bit of change. We use different models now. Some problems that used to be considered impractical are now practical. But one thing that I've observed that has remained the same over all this time, and in fact has maybe become more pronounced, is that in natural language processing, the easy things are hard. The hard things are easy, but the easy things are hard. Let me drill down on this for a moment with a more concrete example. One of the main applications of natural language processing that we look at, and particularly in the group that I work with at IBM, is that of finding facts about people. So you might take a document and extract the fact that Joe is an author of this document. You might get another document and find that this document expresses a positive sentiment towards Amy, or another document says that Lois traveled to California this past January. Right? These are all examples of facts about people that you can extract from text. And the general recipe for finding facts about people with natural language text is 3 steps. First, you find people, then you find facts, then you match the facts and the people. So by finding people, I mean finding places where your document mentions people, either by name or by a pronoun like he or she. By finding facts, I mean extracting instances of, for example, in the first case of the authorship of the document, you might find that this region of the document is the author list. And by matching facts with people, I mean taking the outputs of your people finding model and the output of your fact finding model and figuring out where they line up to get facts about people. So there's these 3 steps, broadly speaking, in finding facts about people. And the first 2 steps are really, really hard. They're so hard that there are entire sub-disciplines of natural language processing where many researchers have spent many years building up the tools and models to be able to do these tasks. The first task of finding mentions of people is known as named entity recognition. The second task, finding facts, well, depending on what kind of fact you're looking for, it has several different names. If you're finding the author list of a document, that's structure identification. If you're finding positive or negative sentiment towards things and people, that's sentiment analysis, and so on. But that third step, matching facts and people, so that's just taking 2 models and figuring out where they line up. That's easy, relatively speaking. But in natural language processing, the easy things are hard. So let's drill down on this and even more with a concrete example, something of a toy version of this problem. I'm going to make this super simple so I reduce the amount of code I have to put on the screen. Well, one example of finding facts about people, if we really, really simplify this problem, is let's find what words occur immediately to the left of a mention of a person in the document. So for example, if our document is Terry Gilliam and the fabulous John Cleese live in England, period. In the context of this document, we have mentions of two people by name, and John Cleese is mentioned to the right of the word fabulous. So the word fabulous occurs immediately to the left of the mention of John Cleese. So we're going to look for instances where pairing these mentions of person names with the word immediately to the left. And you can see how if you had something a bit more powerful, a more powerful fact than word to the left, this kind of pattern can be very useful in a lot of applications. But we're going to do the simple version, word to the left of the person name. Now this is a three-step process. First you find people, then you find facts, then you match the facts with people. In this case, the facts are where are all the words in the document. The people, well, where does the document mention people by name? That's, as I said, a task we call named entity recognition model. And you can get open source and commercial models to do this named entity recognition task off the shelf. Here we have some example code that does exactly this. This is a 4-line program that takes in English language text and outputs the locations of the person names in that text. And a huge amount of science and work went into making this possible. But you as a user just have to write 4 lines of code. Basically load the model, run the model, get some results out of the model, and then filter those results. And you're done. As for that step 2, finding the locations of all the words in the document, now that we've found the locations of the person names, well, that's a task that in natural language processing we call tokenization, finding the boundaries of all the words, the locations of words. And this is a really hard task because anything less than 100% accuracy is not acceptable, and there are lots and lots of corner cases, particularly for languages that are not English. But again, you can get off-the-shelf models for tokenization, both open source and proprietary. And here we have an example where we use the open source tokenizer from the SPACY natural language processing library. And again, it's about 4 lines of code. Load the model, run the model, extract the results out from the model, and you're done. So these hard steps end up being easy because there's so much scaffolding that we can build up. And we're left with this 3rd step, which should be the easy part, matching the facts with people. We've already got the locations of the person names. We already got the locations of all the words. Just need to find the word that occurs to the left of every mention of a person name. Well, the code to do this 3rd step looks like this. This is about as small as I've been able to get it. And you can see that the font size is a bit small, but that's okay. Let me zoom in on just the important parts of what's going on here. So you need to have some kind of data structure, some kind of lookup table, because if you don't, your algorithm is going to be order n squared in the size of the document, and that's bad. So the first step is to build a lookup table with that maps the first location of the first character in each word of the document to the index of that word. Then you look up all of the person names in this lookup table. That tells you what is the index of the first word in that person name, but it's not the first word of the person name that you want. You want to have the word that comes before the person name. So you need to go back to your list of words. When go back 1 in that list of words, unless that person name happened to begin at the very beginning of the document, in which case you do not want to roll around to the end of the document. You have to special case that corner case. And then once you've done that, you need to construct a result vector containing the output and maybe add a little bit of error handling, and then you're done. And what were we talking about? Oh, yes. In NLP, the easy things are hard. And here I've given you an example of an easy thing that's hard, building applications that combine the results of multiple models. There's a lot of other easy things in NLP that end up being hard in practice because you don't get much assistance from the libraries that are very, very focused on these modeling tasks. Things like if you have the outputs of your model, instead of combining them with another model, you might aggregate them to compute a model accuracy. Or you might look at the inputs of your model and look at the training data and so on. Right. All of these easy tasks that are hard, they have something in common. They're all about analyzing data. They're about analyzing the data that comes out of your models. They're about analyzing the data that's used to train your models. And in natural language processing, if you're just working with NLP libraries, typically these tasks are left up to you. But in the Python data analysis area, there are tools that make analyzing data easy. And in particular, Pandas data frames make analyzing data easy. Well, outside of NLP tasks, we know that Pandas data frames make analyzing data easy. And what I'm going to show you in the rest of this talk is that Pandas also makes the data analysis steps of natural language processing easy, with a particular focus on that one at the upper right, building applications for multiple models. But I should also call out places where you can explore further in our code and our examples to look at all these other examples of how you can make analyzing NLP data easy with Pandas. So let's come back to our original toy example of finding facts about people. And here's the code again that does people finding, our 4-line program that takes in English language text and finds people. At the top of this snippet, we have the input sentence, Terry Gilliam and the fabulous John Cleese live in England. If we ran this and we took the output and we printed it, the Python objects that come out of this as text, we get something that looks like this. Well, let's imagine for a moment that instead of a graph of Python objects, we got back a data frame. Now, for those of you who may not be overly familiar with data frames, a data frame is a data table that you can manipulate with code. And this is a Pandas data frame as rendered in a Jupyter notebook that we're seeing on the right. And the first thing that should jump out at you is the thing on the right of your screen right now is a lot easier to understand than the thing on the left. And this is something that I like to call the transparency benefit of data frames. You can understand your data at a glance when it's in this nice tabular format. You can see in this example that there's rows and columns. Every row represents a mention of a person. Every column represents a characteristic of that mention, and you can see nice, clearly laid out examples of the kinds of data that go in each of these rows and columns. Contrast that with the thing in the left, where if you look at that massive text, the first thing you're going to see is, yes, that's JSON data. And the second thing you'll see is that the first line there introduces 1, 2, 3 levels of nesting, and what were we talking about? Okay, so transparency, you can understand your data at a glance much more easily when it's in this data frame format. And we can do the same translation to our word locations. Remember, we're trying to find the word to the left of each mention of a person name. Now we have 2 data frames, one with the locations of our words, another with the locations of mentions of person names. Now we just need to match up these locations, these pairs of locations. Now before, we had to invent an algorithm and invent some data structures to do this, and we ended up with a fair amount of code, even though this is a really, really simple version of this kind of matching up. When the inputs are in data frames, though, it's 1 line of code because you just use a high-level span operation. In this case, we have adjacent join, which takes 2 sets of locations and finds the items from the first set that are adjacent to the items in the second set. And that gives us that does everything we need to do. And this is another characteristic of Pandas data frames, that Pandas comes with a huge variety of high-level building blocks. And for most of what you would want to do in terms of manipulating data, there are building blocks that you can put together to do all the steps of your analysis task. And because you also have this transparency, before and after every step, you have this nice tabular representation that shows you exactly what you have changed in your data. So Pandas brings these benefits of transparency and simplicity that you're probably familiar from non-NLP tasks, and this also is effective in natural language processing. And there's a third benefit that I've actually shown you, but maybe you haven't been aware of that, which is what I call compatibility. By compatibility, I mean if 2 libraries produce data frames as their outputs, those outputs immediately become compatible with each other. Even if the libraries are from completely different places, you have 2 data frames, and any operation that takes 2 data frames now is compatible across these libraries. So here's our code again to combine the outputs of our person mentions model and our word locations model. These are 2 different models from literally 2 different open source libraries, but because the inputs were data frames, they're now compatible. We can now combine them together, and we can extend this further. Imagine if instead of getting our person mentions from the open source Hugging Face model, we had used the IBM Watson Natural Language Understanding web service to do that finding person mentions. You can see the output of natural language understanding is quite different from the Hugging Face output. But if you translate to data frames, they start to look the same. They start to look similar enough that you can imagine the same code manipulating both of these. We can do the same thing with our word locations. Again, take the output of natural language understanding, the output of our spacey tokenizer, change them into data frames, and now they're looking quite like instances of the same thing. And just like we had that one line of code to combine the outputs of the spacey model and the Hugging Face model, we can take any combination of these different models and just the same code works. So Pandas gives you transparency in that you can see your data at a glance, simplicity in that you get high-level operations, and compatibility between libraries. And in NLP cases, this makes it much easier to manipulate the data that flows out of models and into models and between models, which takes the easy steps that are normally hard in NLP and makes those things easy again. So that's the crux of what I'm going to talk about today, that NLP actually behind the scenes involves a lot of data manipulation, and we're going to use Pandas. We're going to show how to use Pandas to make that easier. At this point, I'd like to pause and ask if we have any questions on the chat.
No, I think we're good for now.
Okay, great. So
I have one question, if you don't mind.
Please, Maria.
So what would you use if it doesn't fit in the Pandas data frame?
If the data does not already fit in the data frame, as in it's not in a format that Pandas immediately.
No, if it ends up too big.
If it's too big.
Yeah.
So what you would typically do there, if it wasn't NLP data, is first of all, data frames can hold a surprisingly large amount of data, like gigabytes. But if it's too big for even that kind of a level, you'd split it into multiple data frames. And I'll show an example at the very end where we're dealing with data that you could conceive of it not fitting in one data frame. But if we view it as a problem of let's make one data frame for each document and then combine the results together at the end when we've compressed down the information for each document, we can keep a very large use case fitting in the machine with data frames just by expanding out the size to fit within the machine, getting back down so it's a little bit of the output, and then doing that over and over again. Yeah. So all the tricks basically for dealing with larger data than your machine can handle by itself with data frames, they're also going to apply when your data is natural language processing data.
Makes sense. Thank you. I don't think we have any more questions, so
okay.
Go ahead.
Great. So there's probably one question that maybe people are voicing a little silently here right now, in particular people who in our little raise your hand exercise earlier were in the category of they're already using Pandas for NLP. And that would be that you're probably thinking, wait a minute, all that stuff you showed me, you can't do that with Pandas. And if you're thinking that, then you would be right, because Pandas out of the box doesn't have any way to store like the locations of person names in the way that we showed you. And a couple other things are also extensions to Pandas. And we have at IBM written a number of extensions to Pandas for natural language processing, which we call text extensions for Pandas. Text extensions for Pandas is an open source library from IBM that provides extensions to data frames, to Pandas data frames, to cover the data management tasks inherent in a lot of natural language processing applications. In particular, we add new data types to Pandas, as well as high-level operations over those data types, and integrations with common natural language processing libraries to support creating data frames that out of the output of these libraries that incorporate these data types and let you manipulate this NLP data with high-level operations. You can get this library today with your favorite package manager. We have a pip package, we have a conda package. You can see the install commands at the upper right of the screen. Our source code is also available on GitHub, and we have a homepage, which is ibm.biz/text-extensions-for-pandas. And we'll put these links up at the very end of the talk too. So text extensions for Pandas is our library of extensions for Pandas data frames that made that use case I just showed you possible. And we'll dig in a bit more into the details of this now. So I talked about the extension types we have in our text extensions for Pandas library. We add two particular extension types for covering spans and tensors. And the way that we do this is by leveraging the Pandas extension mechanism. This is something that was added to Pandas around version 0.24. Pandas has a mechanism for users, and as well as for Pandas developers, to add new types to the Pandas data frame library. And the main extension point is a class called extension array. You can see at the bottom of the screen a link to the documentation if you're interested in how this happens internally. The main things to remember here are, number one, this is used by Pandas for many of the newer types that have been more recently added, types for dealing with time, times for dealing with intervals and time series, as well as the categorical type system in Pandas uses extension arrays, and extension arrays allow you to add new types to Pandas data frames and get all of the benefits of a pure built-in type, in that you can have efficient in-memory storage of the data of this type. You can have all the Pandas vectorized high-level operations work on your extension type and be fast. And you can also implement fast binary I/O by leveraging Apache Arrow, so you can take a data frame in your type and say write it out as a Parquet file and then read it back in, even though it has a user-defined extension type. And we've used this mechanism to add extension types to Pandas to cover two very important types of data for natural language processing: spans, which represent regions of a document, and tensors, which are multidimensional arrays and are very commonly used in the modern models for doing natural language processing tasks. A bit more on spans. We saw this example data before in our person facts example, right? We had this data frame with all the locations of the person mentions in the document, and that location of person mentions column, the person column here, is a column of our extension type span. And this holds a series of spans of locations of all person names in the document. Now, if you look at the first row, its string representation is 0 to 13 terigillium. That means characters 0 to 13, which happens to have the text terigillium at that location. The way this extension array stores data internally is not by storing these strings. We store actually two NumPy arrays of begin and end offsets for the entire column and a shared pointer to the document text. Things like this string representation for printing are generated on demand. The internal representation is vectorized and highly space efficient. And if you do like a slicing operation on this, the slice becomes just a view. And when you have a data in a extension type in Pandas, all of the normal operations that you would do on a built-in Pandas data type just work. For example, this particular data frame is the result of processing another data frame containing all of the mentions of named entities. An entity can be a person, an organization, a location. And we did a filtering operation to filter those down to cases where the type of the entity was person, and we did some column projection operations, and all these things that would normally work with built-in Pandas data types. They just work out of the box with our span data type. We also, of course, have some span-specific operations for our data type, like the adjacent join that I showed you earlier, on top of all these built-in operations. So there's a huge variety of high-level operations you can do on spans, which, as I was mentioning, are a core concept in natural language processing, because you need to know what is the mapping between something you've extracted from a model and a location in your document. The other data type that we add to Pandas in our text extensions for Pandas library is a tensor data type, which we call tensor D type. A tensor is an n-dimensional array. It's a very crucial part of modern natural language processing because it's a crucial part of neural networks. And a lot of modern natural language processing models, such as the person location model that I showed you earlier, are based on neural networks, and they consume and produce n-dimensional arrays or tensors as part of their implementation. And it's frequently advantageous to be able to store tensors in a data frame, which is exactly what our tensor type allows you to do. It allows you to define a column in your data frame and have each cell in that column, each row, hold a different tensor. But behind the scenes, internally, we're representing that entire series, that entire column, as a single NumPy array, which allows us to do not only a compact representation in memory, but very fast implementations of a lot of bulk operations over this data. And This has many uses. In particular, we can use it for storing embeddings. An embedding is a very commonly used concept in natural language processing where you take a region of text and you compress down all the useful information about that region into a single dense vector. And that vector is a much more easy thing to consume if you're training a machine learning model. Here, for example, we have an example of embeddings in a Pandas data frame, and if you zoom out a bit, I use this in my own research a whole lot. We build a data frame where each row represents a location in the document. In this case, each row represents one token, one word in the document, and we can use spans to mark that location. We can use embeddings to show a compressed version of the information in the vicinity of that location, and we can add additional columns to the data frame to hold other features of those locations in the document. So our tensor data type is extremely useful for these kinds of use cases where you're matching spans with embeddings. We also can store things like n-grams. We can store image data if your natural language processing also has an optical character recognition component. We can even use these to store time series in each cell of a series. So that's our tensor data type. On top of these span and tensor extension types for Pandas, we also have facilities for doing input and output, both for converting the outputs of common natural language processing libraries to data frames that leverage our extension types, and also for reading and writing binary and text data. So on the data files front, we can support the Feather and Parquet binary data formats, also Arrow Flight for transmitting binary data over the wire, and we can also read in the Cohen LLU format, which is the you can think of it as the natural language processing community's version of the CSV format. We also can, of course, read in the outputs of various libraries. You've seen a little bit of that so far. In particular, you've seen our Spacey integration in that code we saw earlier. Although I didn't keep the transformation wasn't down the screen, but you saw the output of that, the data frame of word locations. That's from our Spacey integration. We also have integrations with Hugging Face's transformer library for producing embeddings. That data frame of embeddings on the previous slide, that came from a Hugging Face transformer library via our transformation, our library integrations. And we also have integrations that will take the outputs of two IBM Watson natural language processing tools, our Watson Discovery Table Understanding, which finds the structure and contents of tables in PDF and HTML documents, and Watson Natural Language Understanding, our web service that can run many different natural language processing models on HTML or text documents. I'd like to pause for a moment, and we've given you a lot of information about our library. Do we have any questions from the audience on the chat at this point?
We don't have anything from the audience, but I do have a couple. I guess overall, maybe it's a better question for the end of your presentation. But what would be, let's say, your sales pitch to people who are watching right now? They probably have an NLP application that they're working on. What's the incentive for them to actually try out and use text extensions for Pandas? Does it make the code more concise and readable? Does it make it faster? Does it consume less memory? Like, what's the main benefit?
So the main pitch here, and you're going to see this demonstrated in the demo I'm about to give, is that if you use the data frames, the data analysis portions of your natural language processing workflow become a lot easier, because you can see the input and output to every step on your screen as a data frame and understand what's happening. And because a lot of these steps turn from someplace where you have to invent an algorithm into one line of code. And that's just like a lot of these common NLP libraries are taking all the work involved in a model and making that a lot easier to consume. Pandas makes the data analysis for your model outputs, for your model inputs, for combining the results of multiple models a lot easier. You can do a lot more high-level code, and you can much more easily understand what's going on. And we have, if you go to our homepage, which I'll link at the end, we have a number of example notebooks which show how a lot of common natural language processing workflows, not just this use case of combining multiple model outputs, but also training models, evaluating the effectiveness of models, looking for problems in your training data, how all of these different uses of natural language processing can go a lot more smoothly if you're using data frames to store and manipulate all of the intermediate data.
Okay, and I do actually have the second question, which is related to a question that we have from an audience. So Tiago from an audience said, like, would it be possible to apply text extensions for pandas to, for example, like koalas, which is a pandas API for Apache Spark? And related to that, my question is, would the same question, but for Dask data frames?
Right. So the support of these data frame libraries for pandas extension types is mixed. I'm not sure if things always would work out of the box. What I can say is we have been experimenting with the pandas support in Ray and using the Ray parallel library with text extensions for pandas. And that's actually been going quite well. And I have a blog post coming out on that. I might be able to give a brief taste of that at the very end if we have some time. But yes, so in particular, if you look at, for example, Spark, Brian Cutler, one of our co-authors on text extensions for pandas, added this facility to PySpark where you can have a user-defined function that takes in a data frame and does data frame manipulation on that data frame of code and then produces another data frame. That kind of user-defined function works out of the box with text extensions for pandas because we have translations built in for the arrow format. So we can actually do that kind of integration today with PySpark. I'm not sure whether that's going to work with a Dask out of the box, and I haven't looked into whether whether it would work out of the box with the Databricks library, but certainly for UDFs, pandas-based UDFs on top of PySpark, it's going to work out of the box, and we've gotten it working with Ray.
Okay, great, thank you.
Great, thanks, Alex. So let's move on to the demo portion of the talk. And this demo is going to be another use case, a more realistic use case in the area of finding facts about people. And what we're going to look for is executive names in corporate press releases. And to remind you, the general recipe here for finding facts about people in natural language text is number 1, find people, number 2, find facts, and number 3, match your facts with people. In this case, people finding, we've kind of already covered. That's named entity recognition. We'll use a named entity recognition model to do that. Finding facts, in this case, well, the abstract fact we're looking for is that a person is an executive. We're going to map that down to something a bit more concrete, which is we're going to look for people who are quoted by name in the press release. Here's an example of a quote and of a IBM executive by name, and the intuition here is if somebody is quoted by name in a corporate press release, chances are that's someone who is authorized to speak on behalf of their company, i.e. they're an executive. So this is a very effective way to find the names of leaders at companies by looking for quotes. Now to find these quotes, we have to deal with the fact that the quotes can take many different formats, and we need a general model that's going to cover all of them. And the way we're going to deal with that problem is by using a model called a semantic role labeling model that is going to look for basically events that happened. And we're going to post-process the results of this very sophisticated, very general model to pull out just the instances of somebody said something. And then we're going to match that up with the instances of a person was mentioned by name, and we'll find a list of all the executive names that occur in this press release. And so let me switch to my other window where I have a Jupyter notebook open and maximize that. Great. I think we can maybe increase the font size one more notch. Just let the screen refresh. Oh dear. Let me see if scrolling up and down makes the screen refresh properly. Is it just for me that the screen is only showing the upper left changing? Let me try. Oh, I got a little bit more in my document. Wow, that is really trippy. Let me restart the screen sharing and we'll get this working for you. Sorry about this. Okay, that looks more like it. I think this time around I will not press that maximize button. So here's our demo setup, and we are going to be working off of an example IBM press release, and I've chosen this press release primarily because it's short and kind of fits on the screen at once. Make the font a bit bigger here. And also it contains 2 quotes from 2 executives. First quote being here, quoting Christoph Hermann, and the second quote being down here, quoting Stephen Leonard. It also contains a name of a person who is not an executive down here. So we're going to look for places where this press release quotes someone. We're going to look for mentions of people by name, and we're going to cross-reference those 2 to get names of executives. So the first thing we'll do is we will do the hard parts of this, finding people and finding facts. And we're going to use the IBM Watson Natural Language Understanding web service. This is a web service that you can connect to on the IBM Cloud for free that will give you access to a number of different natural language processing models. And in this case, we'll use a named entity model called entities and a semantic role model to pull out actions, things that happened. And those 2 models, the outputs of those 2 models gives us everything we need to do this task. The outputs of these 2 models, which you can see down here, are also quite verbose. There's a lot of information here. Buried in that information is what we need to find the names of executives in this document. So instead of looking at this JSON data and writing code to pull out stuff from this JSON data and inventing algorithms and data structures to do basic operations on this JSON data, let's convert this to a data frame. We have in text extensions for Pandas a function that will convert the output of the natural language understanding service, all of the different models that service can expose, into data frames. And the main entry point is nlu.parseResponse. If we call that, we get back a Python dictionary with 1 data frame underneath each of these keys here, 1 data frame for each of the model outputs that has been translated to a data frame. If we look at the entry here for the entity mentions model, we get all of the mentions of named entities. A named entity is something like a person or an organization or a location that's mentioned by name in the document. And you can see that that model has found a bunch of organizations. It's also found some locations and some persons. What we're interested in for this use case is just the person names. Now, because this data frame is a data frame, we can use Pandas filtering operations to filter it. So we can pull out the filter, the person names with 1 line of code, just a simple Pandas filter on that type column. Now we have all of the instances of a person being mentioned by name in this document, as well as information about each, and you can see at a glance what you have extracted. So, by the way, if we look at this column of span data, this is backed by our span array extension array for our span extension type, and all of the Pandas series that are backed by an extension array have a property called array that will give you access to the extension array object. And our extension arrays know how to render themselves in Jupyter notebooks. So if I get a pointer to this array and pass it as the result of my Jupyter notebook cell, I can view all of the spans that are in this column. I can see the begin and end offsets that are the internal storage, and I can see a representation of the locations of these person names within the document. So that gets us to the point where we have found all of the person names, and we have a data frame that shows us exactly what we've been doing. Let's talk about finding the places where a person is quoted by name, or rather where somebody is quoted as saying something. There's this other model that we ran up above of natural language understanding, that's the semantic roles model. This is a semantic role labeling model, which there's a lot of complicated definition behind that if you want the really precise version. But the easy way to think about semantic role labeling is it's looking for instances of things happening. It's looking for places in the document where something happened. And every time that something happens, it's going to extract out a triple of subject, verb, object, subject, verb, object, where the verb is the thing that happened, the subject is the thing or person that made it happen, and the object is what it happened to. So for example, scrolling back up to the text that we're looking at, this is, by the way, is the document text. The document started out as HTML, as you can see here, and natural language understanding has converted it to text, and that text is stored inside of our spans. But if we look at this first sentence in the document, IBM today announced that IBM Power Systems has been certified for the SAP HANA Enterprise Cloud. From that sentence, the semantic role labeling model extracted out several different facts. The first fact it found was that IBM has announced that IBM Power Systems has been certified. The second fact it found is that IBM Power Systems are certified for the SAP HANA Enterprise Cloud. So there's a whole bunch of these facts that this general purpose high-level machine learning model has extracted, and buried in this table of data are the specific facts that we're looking for, namely that a person or organization made a statement. Somebody said something, and we can pull out those facts by filtering this table, by filtering this data frame, by looking at the normalized form of the verb and pulling out the cases where that verb is the English verb to say. If we do that, we can make a much smaller data frame containing just the instances of the pattern that somebody said something. And you can see here that in the subject of this subject-verb-object triple, we have a region of the text that contains a person name. Now we just need to match these up with the person name models from our named entity recognition model output. There's a little bit of a wrinkle here in that this semantic role labeling model doesn't produce spans in its raw output, but we can get around that because it's easy to make your own spans. So what we first, let's take this data frame here and project it down to just the column that we need. We got the subject.text that we want to line up with our person name spans. And we can take we need a handle on the document text, of course. Remember, the original document was HTML. Watson Natural Language Understanding has converted that to text. A pointer to that text is available under the extension array. We could also have gotten that out of the raw output of the model. So we pull the text out of our entity mentions span array. That gets us the document text. Now we need to find the locations of these strings here within that text, which we can do with a little bit of Python string matching. That gives us a data frame. You'll notice a constant thing here. Every step of our analysis, we're doing a small amount of code to go from a data frame to a data frame, so we can clearly see what's going on at every stage. We have a data frame with the original text, the begin offset of that text. Now we can use Pandas built-in string operations to compute the end offset by just adding that begin column to the length of the string in the text column. Now we have begin and end offsets, and begin and end offsets plus the document text we got up here is all we need to make an array of spans. And we can build a span array by calling the span array functions in text extensions for Pandas, passing in the text, the begin and end offsets. You'll notice we're passing in Pandas series directly. We could also have used a NumPy array or a Python list. And out of this, we construct a span array. So now we have a data frame which has the original text, the begin and end offsets, and spans corresponding to that original text. Now we have spans of the subject in that subject said something relationship. And way up here, we have spans of persons. We just need to cross-reference these two sets of spans and look for cases where the subject contains the person name. And that's a span containment operation, which is a basic operation on spans. We have several of those basic span operations implemented both as scalar operations and as joins. In this case, we use a contain join. Contain join just takes two sets of spans, and it finds all the pairs where the element from the first set contains the span in the second set. You imagine a longer span with a smaller span contained inside of it. So we're looking for cases where the span column of the subject's data frame contains the span that is the person mentioned, where there's a subject to a subject said something relationship, and where there's a mention of a person by name inside of that. And if we find all those pairs, now we have the matching between the person name mentions and the subjects. And we have basically found the names of executives in this document. We can do a little bit more massaging here. drop this subject because we don't really need it as our output, and output just the person name and tag on the URL of the document. And now we have a kind of a pipeline for processing a document. And now in this other window, I have gone and taken the code that we've built up here, running the model, doing some transformations with data frames, and pasted that all into one function, which I call find persons quoted by name. And now down here, I've opened up a list of URLs of press releases, and I have then just gone through and called that function on each press release, one after the other. And this is a data mining program. I've gone through about 200 IBM press releases, and I've extracted out from there the names of 301 IBM executives, well, IBM and related company executives. And this should be live. So I can print it again. And if I wanted to just go to the first row, I can do basic operations and pull out a data frame that's one subset of this. And if I wanted to look at what is the context of that first person that we found here, I can pull out that column, and I can drill down to the backing array and ask Jupyter to print that. So now we have this span, Wendy Whitmore, that we've identified as a executive, and right here that we have this quote, the amount of exposed records, et cetera, said Wendy Whitmore, Vice President, IBM X-Force Threat Intelligence. So you can see how easy it is to build an end-to-end application by using data frames to handle all of the heavy lifting of data manipulation and using high-level libraries to do the modeling. You can concentrate on the structure of your end-to-end application. And this is how Pandas makes it much easier to do natural language processing application building. And also, if you're more on the research side, you can apply this same kind of approach to the model building part if you're building your own models, to manage the outputs of your models, to analyze the outputs of your models, or to make new training data for your models. So just to summarize, Pandas makes all of these data analysis steps in your NLP workflow go a lot more easily, because each step is smaller and you can see a data frame before and after. So let's go back to our main slide deck here. And this concludes the demo portion of the talk. How are we on time? 3:52. So we're right on target here. As I've mentioned, I've shown you how Pandas data frames makes natural language processing much easier, much smoother by simplifying all of the data management and data analysis steps inherent in building an application or building a model for natural language processing, and how our extensions library, text extensions for Pandas, extends data frames, extends Pandas with new data types and library integration that allow you to more effectively leverage the power of Pandas in applications like the ones I've just showed you. If you'd like to find out more, we have a number of different notebooks that drill down into these kinds of use cases off of our website, ibm.biz/text extensions for Pandas. You can also try out our library, just pip install it. You can use our notebooks as example code and go from there. And I encourage you to use the power of Pandas in your natural language processing applications. So thanks very much for listening to my talk. We have, I think, a couple more minutes that we can answer any questions, or we could just take a break and until we get on to Luciano's talk. So do we have any questions from the audience?
We had one request for the notebook that you has been showing. Whether maybe you have a link, or you can send us the notebook directly, and I guess after the event we can share it in the meetup group with the audience.
So the particular notebook that I've been showing you is in our tutorials directory. You see the source code link up here, github.com, codate, text extensions for Pandas. If you go to that website, I'll just open my browser window here and go to that website. If we go there, there's a subdirectory called tutorials. In there, there's a subdirectory called market. And this, what I was going through is market intelligence, our market intelligence use case. Market intelligence is mining basically news articles or social media to find information about markets for products. And so the names of decision makers is one of those pieces of information. Oh, something has gone wrong. Okay, there we go. And we have a notebook version of this with a lot more detail in the interstitial text. And there's a blog version of this that should be coming out in a couple days too. But you can go to our source code and drill down into the directory called tutorials, and you'll find this notebook. There's also a part 2, and we're working on a part 3. So part 2 is getting a bit more deep into some more advanced natural language processing technology involving deep parsing. And part 3 is talking about how you can get better performance in these kinds of applications by being clever in your use of pandas to avoid running your models over the entire document. So yes, all of this code is available with a lot more explanatory text in this tutorials directory. And we have some more lightweight notebooks in this notebooks directory in our source code. And if you come, let's go back to the PowerPoint. If you go to this homepage, you'll see that links off to the contents of the notebooks directory and provides you an introduction to what each notebook's going to do. So did we have other questions?
No, I don't think so. Maria?
I don't see any more questions, but thank you so much. It was a great presentation, and you gave us a lot of material to play with, a lot of tutorials and notebooks to go through and to check and to try it out. It was very interesting, and I think it is a very useful set of extensions for Pandas, specifically for these tasks. And it was a pleasure having you. Thank you so much for joining us. And I see that folks also enjoyed your presentation a lot. So we were happy to have you. And now I think it's time for our second presenter to join, Luciano Resende. I'm going to add you to stream. Hi, Luciano. Let's switch the screen sharing to... Oops. No. Everything's right.
Let me start my screen sharing here. Give me 1 second.
Sure. Yes. All right. I see it. And I've added it to the screen. So now I'm going to remove us from the screen, and the floor is going to be yours.
Oh, great. Thanks, Maria. It's very hard to be after Fred because he's so an excellent presenter with an excellent topic. So we'll try to get close to that, but I know how it is. Thanks, Fred. And today I'm going to be talking a little bit about extending JupyterLab for AI, and it's a project that we are doing called Elyra. But let's start a little bit about me. And I work on the Code Day, which stands for Center for Open Source Data and AI Technologies, together with Fred. I think we started the Code Day sort of like a few years ago. It used to be named Spark Technology Center, and we started seeing a lot of like expanding the scenarios in the areas, and that's how we became Code Day. I've been contributing to open source for a long time, over 15 years. I started with Apache and a lot of projects there on the SOA, then moved it to Data. And today I contribute to some Spark related ones, but focusing a lot more on the Jupyter Notebook ecosystem, the platform to build AI in machine learning, integrated with a couple of other things around there. If you need to contact me, here's everything that you need to know. My email, Twitter, find me on GitHub, LinkedIn, and you name it. I usually respond very quick, so just feel free to reach out and questions or suggestions or anything. I talked a little bit about Code Day already. Sort of like want to mention the Code Day it's a group at IBM, an organization at IBM that really just kind of like concentrates on the open source. So everything that we do, as Fred was saying, we go directly with the community. If we are doing things on TensorFlow, PyTorch, and you name it, we have communities, we contribute there, similar to notebooks, similar to Spark contributions. We're also doing Kubeflow, and so it's very the scope of our contribution is very big. It goes and it contributes, and discussions and everything goes directly to the community, and we follow the community time frames and everything. It's not related to the IBM products and anything. Having said that, we are sort of the bridge when they need something specific or some kind of capabilities that a specific technology does not have yet, or to apply some of the enterprise capabilities there. A couple of areas that we have been working on, just FYI. So using AI, we have Model Asset Exchange, Data Exchange. Around AI frameworks, we have been contributing to TensorFlow, PyTorch, Scikit-learn, Pandas. For building AI, so all across Jupyter, so Elyra, Enterprise Gateway for scalability, JupyterLab, JupyterHub, and Jupyter. Around data and AI platforms, Spark and Kubeflow are sort of like the main ones we have been contributing, and also various areas around trusted AI. And there are other projects that I might have forgot here, but it gives you kind of like the different areas, what kind of like projects we are contributing. This comes from our group, and also like doing bridges with either products or research labs around the world. So that's kind of like good to have those capabilities inside and outside of IBM. But let's start talking about what I'm really here for. And I'm assuming that we are here in PyData sort of thing, so you guys know about notebooks. But maybe we have a couple of folks that are not so familiar with that. So let me kind of like quickly jump here and then get everybody on the same page. So what is notebooks? Notebooks gives you interactive computational environments. You can start not only putting code there, but you can start combining documentation with your code. You can have a very interactive aspect to it, where you execute a piece of code, you maybe get a response back, you can plot something, you can really use that capability to start understanding what you have. When we look into data science, understanding the data, getting to a scenario where you feel comfortable with that, and you can start moving to the next steps, all very interactively and so forth. Why notebooks, and why notebooks sort of like became today the de facto place for doing a lot of like data science and AI models. First, very easy to use, very simple. You go to a URL, you get all the power you need for a development environment in that page. Kind of like work as a service, and everything that you need is there. I mentioned already, it's very interactive, so you have interactive widgets. You can get very rich outputs, and that gives you a lot of power to start understanding and look into the problem at hand. Language of choice. All of this does not make you focus on one language, particularly with the data scientists. We know they have different backgrounds, they might have different preferences. Some folks prefer Python, some folks prefer R, Lua, and you name it. And pretty much any language or script that you think about will have a kernel that's going to abstract and give you that script environment in the aspect of the notebook. Integration with big data, so Spark is there. And when you're done and you need to share, collaborate with others, very easy. It's one notebook, packet it, and send to your friends via email, or maybe just push it to GitHub, and you can start getting feedback. People can run on their environment. So all of these characteristics make notebooks very interesting, very widely used on the community today. When we look into how widely use it, this is probably a 2 years old or a year and a half old sort of information, but gives you kind of like a 73% of people are using notebooks. And for kind of like VS Code is commonly coming close in second place, but it's still like below half of what the usage for Jupyter. Also, when we look into adoption in terms of industry, a lot of the companies are definitely using and let people know that they are using it. We can see here a lot of like academics. Jupyter notebooks came from academia. And we also see a lot of like all the cloud vendors and all the big companies also contributing or in using that. Not necessarily this is a complete list, but definitely some big names here in case you want to just know about adoption. Having said that, what you're gonna see today in terms of like the next generation of notebooks is what we are called JupyterLab. JupyterLab is a refactoring UI. When we look into the old classic notebook, it's sort of like give you a one tab that you can only have like one notebook. JupyterLab starts taking this really towards a more IDE environment, provides you different capabilities. You can have like notebooks besides each other for helping you comparing. It can have viewers for different types of file types. Basically, it goes more towards an IDE, gives you all the capabilities that you need. And if we look into different how it is structured, the UI, we can start seeing the file explorer, and then on that kind of like sort of like tab, you start seeing other capabilities there for like seeing what is running and things like that. The widgets give you capabilities to show results interactively, also manipulate those. You have access to console, basically go to terminal. Tabbed workspaces where you can have multiple files open and the text editor as well. And that is sort of like some of the basic functionality that we see on JupyterLab. But when we were working on this, particularly on the code day side, I was helping a couple of teams, kind of like when we were doing Max Index, and also other folks that were doing sort of like the platform. And we started seeing a lot of like gaps there in terms of how do we get to make it easier to do things in the notebook arena, particularly when we are applying sort of like enterprise scenarios. Enterprise scenarios starts to become very big type of applications, and you not necessarily only using the notebook, you might be trying to combine a couple of other things. And based on those gaps, based on the feedbacks with the data scientists, we start looking to how could we solve that. So what is Elyra? We are here to talk about Elyra, and Elyra basically is a set of extensions. It comes to make, like, if you love JupyterLab, Elyra then comes to make JupyterLab even better, particularly if you're doing AI or data science kind of like scenarios. Couple of the functionality that we bring on top of JupyterLab. So it's a pipeline editor. We start seeing that when you're building a solution, you probably want to have different aspects of the model development life cycle as different notebooks, and then be able to compose that into a complete pipeline that you can basically run or schedule or basically do it so that you can do it separately, but you can aggregate that into a pipeline. Also, sometimes notebooks, you're building a model, you're testing locally, maybe with some sort of like a partial data, and then you want to schedule that, run as a batch job, so that you can take advantage maybe of accelerated hardware such as GPUs and stuff. How do you do that? So Elyra makes it very easy to accomplish that. We talking about notebook giving you a lot of kind of like a support for different scripts. We started seeing which ones are sort of like the most used ones. So Python and R script. We identified those as initial ones, and we sort of like making the support in the notebook kind of like as a first class citizens, sorry, and giving you the ability to, without leaving the JupyterLab IDE, to be able to edit those, execute those, and by executing, we also make it very seamlessly for you to execute either local or remote on the cloud, for example. We also want to make data scientists very productive. There are things that we sort of like can reuse a lot. So we created a ability to support like code snippets. Those code snippets can be tagged by language, by category, in the sense of like a matplotlib type of code snippets or pandas types of code snippets. And we make very easy for you to later on then search, select by tag or do a full text search there and easily just include that into your notebook or your Python script. And we will see a lot of this when we go to the demo. I just want to give a very high level here. And we will go to live demo where we expose those. Also, we have integration with Git. We talked about collaboration. We talked about sharing these notebooks with others to get feedback, or basically just share the work that you have done. Very easy to integrate with Git. You can also get other projects from other people to take a look, to collaborate, or to kind of like base your work on that. So these are some of the basic high-level extensions that we have. We also work very close with the JupyterLab and Jupyter community in general, helping and enhancing the platform to get things even better for the community. I talked about pipelines. I talk about kind of like the supported files that I mentioned here for building a pipeline. We currently enables you to associate notebooks, Python scripts, and R scripts into the pipeline. And we also, for the Python and R scripts, we have the editors there. For executing those pipelines, we sort of like have what we call 3 different runtimes. The local mode, which is sort of like use it more in the development phase, where you have your artifacts, you're building kind of like that pipeline, and you just want to keep trying to see if everything is going okay. Later on, when we are done and everything, you might then submit or even schedule and do things on a particular runtime that is more like a cluster that is available for you. And what we support is that you can offload that execution of the pipeline to a Kubeflow. So basically using Kubeflow pipelines or an Apache Airflow as well. And the benefit, and you will see when we go to the demo, is that we hide, basically Elyra does a lot of magic to hide the data scientist, the machine learning engineer from a lot of the required DevOps tasks, and really allows you to focus on the problem at hand here. So that gives a lot more flexibility for the data scientists, give you sort of like a no-code experience where you will get sort of like the notebooks and Python scripts that you have there, build and then select which runtime you want to execute, and you just get that without knowing anything about that runtime to a certain extent. So I think we could stop and see if we have any questions here before we start actually seeing all of this in practice. Any questions?
No, Luciano, I think we're good.
Good. That's great. So let me stop here. Let's go here. I don't know if I want to push the full screen and get to the same thing that Fred got, so I'm just gonna avoid doing that. And hopefully you guys can see the screen okay. So let's start to where Elyra is. If you guys are interested on
Could you zoom in a little bit?
Is it better?
Yes, it's better.
Okay,
Thank you.
perfect. So Elyra, and we're gonna have all these links on the last slides as reference. So Elyra is available on github.com/ElyraAI/Elyra. That is the main repo where sort of like all the extensions and everything are aggregated. When you go there, you're gonna see all the details on what we have, but also like how to get installed or how to start using Elyra as well. We welcome contributions as well if you guys are up to it. It doesn't need to be always towards kind of like big features and coding. Even like if you find the documentation or examples that are not very clear, always reach out to us, create an issue, help us. That is also always welcome. On the top right here, you have kind of like the link to the documentation, which will bring you to the reader docs for Elyra. And here you will have a lot more information to get you started, how to use it, recipes in terms of like deployment and integration with different runtimes. This goes a lot more towards kind of like a self-service deployments, integration with JupyterHub, and more details on the integration with the runtimes as well. And once you have installed, basically the next time that you launch the JupyterLab, you start seeing the Elyra section here. You'll start seeing pipeline editor. You have then the ability to create the Python files, Python scripts directly from here. R script is directly from here as well. And this gives you quick access to the documentation, which we just came from there. Let's take a look at what it takes to build a pipeline. So here is a pipeline that I already sort of like created, but let's try to add things to that so that we know what it would take. Let me get another script here. So you can basically just drag and drop files. In this case, let me drag and drop a factorial here, which is our R script. I can basically get there. And you see that by default, I will get a red mark here because I don't have all the information necessary to run that. Once you click on Open Properties here, you will see that on the side file, you now get a very detailed page with what is required there. You can see the file that is being used, and you can associate a runtime image, which is basically a Docker image that is going to be used when you execute that node on the platform. Note that this runtime image is used in the runtimes. It's not necessary for the local mode, but in this case, it gives you the ability to have an environment that either is customized to your needs, or, for example, in this case, because it's an R script, it's an image that have all the R libraries and that the R environment installed and ready to run there. You will have a different set of properties for each of the nodes. And currently, as I mentioned, the files that we are supporting are these 3 files. Other than dragging and drop, you also have the ability to sort of like drag a notebook here, go back to the properties, and select the file. And these are the direction here is that currently we are supporting this. We are very hard working that probably we are targeting the next release. We are going to expand this to a lot more components. So basically, if you are building a Kubeflow pipeline, and you know that Kubeflow have, for example, support for components that help on the life cycle of the model development, such as deploying a model, training, and different things that you need there. It will be available here as one option, kind of like group it by a category, and you will be able to start dropping those additional components directly into your pipeline and being able to do even more without having to add a lot of code to get what you need ready. And the good thing is, sort of like that is all you need to do. You can see that what I have here are simple notebooks. In this case, I have two steps, two nodes that were generating data for me, and then an extra notebook that basically was aggregating. This is just to see like how many contributions we were having on our particular repository or a particular project. And once you are ready with your pipeline, you can easily start executing the pipeline. So I mentioned the local mode. Local mode will just use my current environment and execute that pipeline. So in this case, if we go here, and let me zoom in, we can see that this is being executed. You can see kind of like the threshold of the execution. And when we go back, it hasn't done all of those yet. But we will see that the submission has been succeeded and all the updates have been completed here. Without doing any modification or anything specific to any of the runtimes, I can also come here. I can say I want to run on an Airflow or I want to run on a Kubeflow pipeline. I can have what we call runtime configuration, which is basically a pointer to a specific runtime that you might have. And from there, you can basically execute your pipeline. Same thing, we package as needed, and we go and submit that to a Kubeflow pipeline that was associated with that runtime configuration. You will see here that it starts execution. And once you click, you can go to the log, see what's happening. I think in this case, it's still just bootstrapping, but you will see the execution there. If we go back here, we can look at the previous one that I was testing, so we don't have to wait for the execution. And in this case, you will see all the nodes here. And because this is the previous one, it didn't have the DR node in that. Now, let's go and do a couple of other things that we showed. So like, if you're just doing regular notebook things, we also have worked with the JupyterLab to enhance navigation. So you have the ability to kind of like on the TOC now with a much better kind of like a style around it, navigate through your notebook. That is very interesting to have in large notebooks. We also did that if, for example, you are on one of our editors to do that with Python scripts. As for the Python capabilities and DR capabilities, let me go and open some here. So this is just a regular Python script. In the past, you had to either have a terminal or some go outside to execute. Now we have integrated. You can, with the Python editor, you can click here and execute. You can also select which kernel you want to use. So if you have multiple Python kernels, and then once you execute, you will get the output available on this bottom part. There are times maybe you have a script here that can leverage GPUs, and you can execute that with the AI runtimes that we support. Clicking here allows you to basically select a runtime, and this will create a kind of like a one-node pipeline, but it hides the complexity or anything needed from you, and you can just execute that. Similarly, same things if you're using R, you can just go here, select execute it. You can select different kernels as well. In this case, I only have one kernel, or you can run as a pipeline that will generate a one node pipeline. Other things, code snippets. Code snippets allows you to easily kind of like share things. So let me just create a new notebook here. Assuming I want to do plot stuff, I can. I have kind of like a couple of things here that help me set up Matplotlib. In this case, create a simple graph here. So just by dragging and drop, those get inserted into your notebook. It can be a Python script and an R as well. And when I go to execute, oops, I might have to install Matplotlib, but I can easily. In this case, let me just see it's done. Let's see how I need to restart the kernel. Okay, but basically would need another. But assuming your code snippet code works, you can just drag and drop, and you'll have that capability of reusing code very very accessible from within the IDE for you. Other things that we have integrated for both notebook and Python scripts is the ability to do kind of like a LSP. LSP is kind of language server protocol, enables you to have the same capabilities that if you're using an IDE, you're very familiar. You can do like refactoring. You can do sort of like see like a linting in other things directly from your IDE. If you go here, for example, you can rename, so do the refactoring. If you go to some particular, let me see, I have another example. So if you go and you go here, for example, you want to jump to definition, it brings you back to where this was defined. So all the navigation, all the things to find on particularly good for bigger code base, it's all now available for you directly from JupyterLab. So the idea is get it an environment that is even easier for you to start building models and AI solutions directly from JupyterLab. Let me see if I missed anything. Let's just take a quick look here. The Git integration, it's also available directly from here. You can easily click here, and if you are on a directory that is backed by Git, you can start seeing kind of like the diffs on the file. You can see you can add to stage it to be committed, and you can commit or pull and push directly from here. You can also, once you are on the main kind of like file browser, you can do git clone if you are, and you can just have a git repository URL, and it will clone that here. For collaboration, for example, if you have somebody's project, you can easily just clone and start working on that, push back some of the suggestions that you have and things like that. All very integrated here. And I think in terms of high-level demos, that is it. If you guys are interested, another project that Fred worked is a COVID notebook scenario. The COVID notebook scenario sort of like uses Elyra to drive and demonstrate very complex scenario, more like a real use case. It goes and consumes real-time data from multiple sources to and manage, put together with combined together with census data to give a lot of like analytics and insights from COVID, particularly on your area of residence, so you can change and manipulate that. This also uses some of the integration that he was mentioning with Ray and the Pandas extension that he demoed on the first part. And you can see a lot a more complex and very more rich notebooks that have been used here. So it's another example. If you guys want to access that, that is also available on the same similar URL. It's just COVID notebooks instead of like a text, the text Pandas text extension. Any questions from the audience so far?
Not from the audience, but I do have a couple of questions. One is, so you support task execution through Apache Airflow, and I was wondering if on the roadmap you have support, for, you're planning support for others such as Luigi or anything else.
So what we try to do on that aspect is it's a work with the community. The addition of new runtimes, we have defined a very pluggable interface that can be done and integrated. But we, to a certain extent, if we go very broad, we will not have the capability to maintain all the runtimes. What we welcome is other communities that have those runtimes talk to us. We'll definitely give all the details on what it takes to build the extension, and we will gladly help to maintain and adapt the necessary requirements for that. But we really welcome and would like a contribution or help from them to get additional runtimes added to the project.
Okay, thank you. So we do have a question from a member of the audience. David is asking, can we connect to Spark clusters with Kerberos authentication?
Kerberos is always the good question. So I can probably I would probably say yes. I haven't, and to be fair, I haven't tested this scenario in particular. If you are running from a kind of like a KFP or Airflow, but the execution uses can use Enterprise Gateway, and Enterprise Gateway is another project that we have working on, and in that we extensively tested with Kerberos. So if he has a specific requirement or a specific deployment that he wants to see working, please raise an issue with our Elyra repository, and we will definitely get back to you and help get some sort of like a test environment, particularly on the use case that you want to see, and make sure that we get that working. But I would say probably the support is there because we can leverage Gateway that has completely support for that.
Okay, and again from David, I guess clarifying questions. What about regular Spark clusters, or in this case, would you simply use PySpark?
Yeah, we will make sure that the infrastructure is there, but then when you code your notebook or script, you just use kind of like a PySpark and stuff, and then everything else works from there. With the Enterprise Gateway, we also support give you the ability to do Spark on Kubernetes and a remote Spark. In that case, you might need to either use or add a customization to your runtime image, the Docker image, but the support is there. We tried it in different ways. So yeah.
Okay, and one question from my side is, when you were showing kind of Git integration and the ability to do diffing, so that's kind of made me think that the extensions are kind of moving JupyterLab closer to like a full-blown IDE. What are other features that Elyra either has already developed or are on the roadmaps? Like, what about debugging, maybe placing breakpoints in your code and stuff like that?
Oh, that's a good question. So let's go and see it. So what you're talking, let me go into my Python script. And let me select. So with the integration with Zeus Python and JupyterLab 3.0, the debugging is now available here, and you can execute and start setting breaking points and stuff. So let me try to give me 1 second. Let me get my factorial. Let me go to this. Let me go to that. Kernel, let me change kernel. Okay, I need to do one more thing here. It's just the screen is getting too small. But now you can see that I can set breakpoints. So the capability is there. And then when I execute, the breakpoint is here. You can kind of basically the notebook UI on the right side will give you the ability to view the variables, kind of like a step through these items, and so forth. So the only caveat here is the kernel needs to support the kind of like a debugging protocol, and it's not all the kernels that are supporting that. Zeus Python was the first one. Zeus Python is a new Python kernel that is available on the Jupyter community, but the IPython is soon going to support that as well.
I have one more question, if you don't mind. So when you were when you were showing how to build pipelines, and so you drag files and everything, I noticed that for each step you have dependencies, like if there's a file or something else. But can you specify also conditions? Let's say, if something happens, if the result of one notebook, for instance, is not good enough, I don't want to run the rest of the pipeline, or maybe more complex conditions, even file is not existent, schema is not matching.
So I would say yes and no. This is one of the things that we want to make even better a UI, to be able to specify the conditions and if then else or a couple of other conditions from the UI. What you can do, and it's sort of like a hacky way, is to kind of like call to the execution of that node 3 based on some value that is available. I think Patrick had created an issue where he described that, or I don't know if it's an issue or a sample. I can find that and send your way that demonstrate more details how to do that.
Sure, thanks.
Oh, thank you.
Alex, do we have any more questions?
No, I don't think so. I think we're good.
Okay. Then please do go on.
Okay, thank you. And I think I'm pretty much done here. I think I just wanted to wrap up with a couple of things here. If you want to get started with Elyra, you can have multiple ways of starting it. Using Binder is the simple way. You go through this and you get kind of like an environment launched for you. You can also run Elyra from Docker, just in your own laptop or your environment. Or you can try Elyra installation directly on your laptop. You can either do a Git or sort of like a Conda installation, and Elyra is going to bring all the environment there. Also, we are kind of like a open source project, so we welcome contributions. Star us and fork us on GitHub. That is, I mean, very, very good for the perception of the project, but also like forking and contributing back. It's even better. Details on where to find installation, our source code on GitHub, documentation. We also have a Gitter channel where we talk. We don't talk too much, but we talk with all the community that get there. I think we write more code than talking there, but I know we can all change that with your presence there. So go there, ask questions, but also go to the GitHub, create new issues. We also have a discussion place there. So we are there to hear from you, get your feedback, and get this even better for data scientists, AI engineers, and you name it, to make it even easier to build applications. Thank you very much, and feel free to send me email or reach out if you have further questions later on.
All right. Thank you, Luciano.
Thank you.
Alex, can you speak a little bit louder?
Right. Thank you, Luciano. So I think we are bringing everyone back up on the screen, right? Fred and Tim. Yeah, so Tim, Fred, Luciano, anyone wants to share some final thoughts, closing notes, anything about IBM data science community?
No, nothing in particular. Thanks everyone for coming and for listening. And you heard it from Fred and Luciano. If you have any feedback or input, just reach out. And yeah, and come check out the community. We have events coming up with that we host, that our partners host, other organizations like PyData that we work with. So definitely give us a look. And yeah, thanks again.
Okay, thanks everyone in the audience for joining us today, and special thanks to our speakers today for putting in the time and effort to share your project with us.
Thank you.
Having you.
There was one more question in the one more question. I saw something in the chat. Elyra, future roadmap. Can you like say one word or two, Luciano, on roadmap?
Definitely. So one of the things that we are working very close, and I mentioned a little bit, is to get a richer component palette into Elyra. After that, we have sort of like we'll be looking to adding more data capabilities, looking into what it's getting it hard for accomplishing the day-to-day tasks of a data scientist, and trying to simplify that. There is a bigger and more detailed list of issues that are tagged roadmap in the Elyra repository. You can go there and find all the details. These ones that I mentioned is probably things that we're going to be attacking by the end of the semester or a little bit after that. And if you have additional requirements or additional requests, feel free to suggest or talk to us, we'll definitely put into the backlog. Consider that sometimes with a higher priority, depending on basically we are a small team, so we can sometimes not be able to get all of that at once. But in the worst case, we welcome your contributions.
Thank you. Once again, thank you for presenters for excellent talks, and thank you for our audience to finding time and spending it with us. And it's been nice to see you all, and we hope to see you again in real life. Until then, see you next time.
Rest of your day. Bye.
Goodbye.
Bye. Thank you, everyone. Be safe. Bye.